Hello, hello. Welcome to yet another episode of the Solfate Podcast, where we chat with founders and builders in the Solana ecosystem, and sometimes not the Solana ecosystem. But today was another Solana-focused episode. We talked with Robin, the founder of Raiku. It's, I'm probably going to use the wrong terminology to describe this, but it's a network extension type work, right? So Raiku is basically building a system to improve the coordination on Solana so that transactions can get included faster, can be guaranteed ahead of time so that you can know for a fact that you'll be included, right? All kinds of things that are required for performance systems. It honestly seems really, really cool. They're in testnet right now, so a little bit TBD on how it behaves in the wild, but really fascinating conversation.
Yeah, it was really, really great. Impressive, I think, of what they're doing. They're definitely solving, like we allude to in the episode, there's this inclusion problem that happens on the Solana blockchain. Generally, users don't experience it with their transactions, but once there is like intense network congestion, it becomes apparent. The Anza and Firedancer core engineers making tons of improvements and trying to solve these problems, but having these types of extension sidecar type flows like Jito, like Raiku, I think is very, very interesting. Super excited to see where Raiku goes.
Yeah. Before we jump into the episode, quick shout out for Unboxed. Unboxed is a dev shop that I've been running for the last decade. If you've got any software needs, feel free to reach out at beunboxed.com or reach out to me on Twitter. We do a lot of 0 to 1 work for founders and companies that are trying to bootstrap new products. So reach out if that sounds interesting to you. We're always here to help. And Nick, you wanna plug your
let me shill. I have a new project, a new company. I'm leaving Solana Foundation, and go to usedecal.com to find out more. Join the waitlist, get some alpha.
Nice. All right, let's jump into it.
Nothing in this podcast is or should be considered financial advice. Any opinions and thoughts expressed are solely those of the individual. They do not represent the opinions of any entity. Enjoy.
I want to start off by hearing the elevator pitch for Raiku, what you guys are building, but then I'd love to pivot and hear more about you personally, Robin. So maybe just tell us the 60 seconds or so about Raiku, and then we'll have sort of more personal discussion and then go back into Raiku and go more in depth.
I'll keep it short and sweet. Raiku is making applications on distributed networks, so Solana in our case, as fast, powerful, scalable as any traditional systems. And we do this by rethinking how applications are built from first principles and how users are interacting with those applications. So basically make crypto apps as competitive as they can be. And that's the only way we can really make sure that all the applications and users can benefit from the crypto that we love today, right? So that's what we're doing.
Okay. So Raiku is building technology that sort of rethinks the crypto experience so that you can get the best of both worlds. The decentralized, trustless nature of blockchain while also being as performant as maybe like a Web 2 system?
Exactly. So historically, the way applications have squeezed the juice in order to be performant is, let's take Hyperliquid as an example. You have a fairly limited validator set, which is operated by limited people, and it's really its own sandbox, right? It's a sandboxed environment. It hasn't really been possible to create the similar type of trading experience that you get on Hyperliquid directly on L1s for obvious reasons, due to the main limitations of L1s in itself. You can only get information to propagate as quickly on an L1 that physical laws really allow for, right? But even if you get it down to, let's say, 120 milliseconds, that's kind of the bedrock. It's not going to get much faster. 120 milliseconds compared to traditional systems is shit. It's really slow. So how can you solve for that, right? So L1s, they have fundamental limitations. And historically, L1s, they haven't been able to optimize for where the transaction originates in the world, right? Solana is trying to do this with multiple concurrent leaders. Alpenglow will also obviously help to reduce the overall time frequency and time games on the L1 in itself, but still you hit the same issue, and L1 has fundamental limitations. So, yeah.
Got it. Well, I'm super fascinated to dig into sort of the how of all of this, but I do want to do a quick, maybe like, what is your background? How did you get into blockchain in general, and more specifically, how did you get into this? How did Raiku come to be? That sort of thing.
Yeah, I've been in crypto since 2015. It's been a while. Seen a lot of cool projects. Mostly worked in Ethereum. My interests when I started was on how we can tweak different incentive mechanisms to reach consensus faster. So I started doing mostly research work in a project called Hyperledger. So pretty much the corporate version of Ethereum, led by Linux Foundation and IBM. Worked with end-to-end teams on Ethereum that led up to the DeFi summer. That was a great experience. So you could really see the entire industry and ecosystem taking shape. But at the same time, throughout that process, that's when L2 started to take shape, and okay, we need to scale the underlying L1 because it's just too slow. And we thought we had the answer with L2s. But that led to so many other problems that we see today, right? Like state fragmentation, incentive misalignment, user fragmentation issues, and not optimal. So been in Ethereum for 6-7 years. Then I joined Solana, the light side or the dark side, depending on how you look at it, at the end of 23. So Raiku started as a research project with a very simple idea that was primarily based on proximity of computation matters. So basically, you want your transaction or your event to be computed and actioned close to where you are. That most likely means that you are having an off-chain component, right? But an off-chain component is underlyingly limited by the limitations of the L1. And if you put an off-chain component on an L1, which is slow, not great. So the idea was, okay, let's explore what this would look like on an L1, which is fast. So I started to look into Aptos, Sui, Solana, and Solana stood out for many different reasons. But that was kind of the journey, and all of this was started by a lot of frustrations that I'd seen in primarily Ethereum, and I mentioned some of them.
Got it. What were those reasons that stood out to choose Solana over the alternatives at the time?
So this, for context, this was November 23. So at the time, it was also a really bad bear market, like literally nothing was going on. But Solana at the time had reached a good state of tech maturity. So the underlying protocol was really advancing. You could see that the core developers was pushing updates like literally every second week. Fantastic, right? There was also a clear
pros
plan
and cons,
on how. True, pros and cons. That's for sure. Move fast and break things. But anyways, the overall tech maturity was getting there. Don't get me wrong. There's still a lot we need to work on, but we're doing that, right? But more interestingly, there was a lot of applications in the ecosystem that was naturally gravitating towards this edge computer extension idea, but no one really knew how to do it. And for context, edge computer extensions is primarily a concept of off-chain compute to make a process just much more efficient. And then you use the underlying L1 Solana as the base of truth, right? So there was a lot of projects back then that was naturally gravitating towards this to make their app a lot more, market competitive, to facilitate for new markets, such as like a perp dex, for example. But all of them had the same issue, and that was, how do you do that on Solana? Because historically, we've seen off-chain compute and external components on other ecosystems, and the most prominent one is Ethereum. So what ended up happening back then was that projects took frameworks, overall solutions that was made for another network, another ecosystem, and it was kind of force-fitting it into the context of Solana, which doesn't lead to optimal results. The third factor that stood out was the user base. You could see that it was growing, and it was growing fast. I think between 2023 to 25, the developer mindshare have gone up like 18.5x, like an insane amount. So user base and developers was just flocking to Solana. So you could clearly see that this is the future. That's why it stood out.
Yeah, it's interesting to hear you say some of those things, because like from my time at Solana Foundation, like we definitely saw that massive growth, and we definitely saw basically exactly what you described, like the idea of like people were taking these, call them bolt-on add-ons for lack of better phrasing, from other ecosystems and other blockchain architectures and trying to make the same thing work on Solana. And it just doesn't, because it's such fundamentally different architecture and like different limitations, different design, all of these things. And yeah, like we've had a show before with Termina about like network extensions and some of the things that they're doing, which is pretty cool. Would love to hear sort of the architecture of how Raiku does this, and does it in a Solana native way built for the Solana chain specifically.
Yeah. So I think we can actually take one step back first. So just to provide helpful context, extensions or off-chain compute components, they will face a number of issues which are inherent to Solana, but also in the general context of L1s. But number one usually being the factor of predictability. So if you send a transaction on Solana today, it doesn't matter if you're an L1 application or a external component, you're always hoping for the best, as in it's an optimistic scenario and you're waiting for it to be approved. You don't know before you send it if it will be, right? So the level of predictability is quite important, especially for larger applications in more traditional sectors. That's a big one. The other problem is if you're introducing many different separate systems as extensions, and they have no way of talking with each other, then suddenly you have the fragmentation issue, and we've seen that elsewhere. The other issue is also validators on the network. They don't necessarily have a way to participate in the value creation of this, which further increases the incentive misalignments and
you mean specifically value creation of things in this like off-chain compute, external compute model? Okay,
exactly, because you, as an external system, you're sending transactions down to the underlying L1. That means that the validator somehow is partaking in that. You want the validator to be as closely aligned with that system as possible, such that they can prioritize system reliability as best as they can, right? And also efficiency, which is like the latency games and stuff like that. Now, that's a really difficult problem to solve for, because you need to be directly working at the validator level whilst facilitating the communication with these other external systems, right? So that's a problem that was quite prominent. It's made harder if you want to have one external system talking with, let's say, an L1 native application. So traditionally we call that state composability. Even harder if you want to have two external systems trying to talk with each other via the L1 as well. Again, state composability. So those are like really difficult problems to solve for. So that's the base of where we started. And I guess now we can go into how we're doing it.
So then how does Raiku actually accomplish this?
Yeah, so Raiku consists of two primary components. One is the sidecar, which is working at the validator level. So the sidecar is pretty much working with the validator to ask what block space in terms of resources or compute units can we reserve ahead of time, such that we can distribute this to applications, which is either directly on the L1 or externally as network extensions or off-chain compute modules. So the sidecar is doing that, and it communicates with the second component, which is the coordination node, which is ancillary to the network, and that is where most of the magic happens. That's where we enable and facilitate the outer protocol transaction types, which is more powerful ways of basically sending transactions to the network. So those are like the two main components, and most of this is driven by ahead of time block auctions, which is being facilitated between these two components or by the two components.
So that sidecar piece, it sounds like, helps to solve a couple of those problems in one go. It allows validators to participate in the value creation because they are participants in this ahead of time, block auction, right? So they can collect fees that way. And it also presumably there's better coordination with these components as a result. Yeah.
Yeah, exactly. And the sidecar is compatible with Agave today and will be compatible with FiDancer later this year, right before mainnet. So yeah, that is what facilitates the communication you need to have with the underlying network in itself.
So this is something, if you run an Agave validator, you can basically install sidecar, in your existing setup.
Yeah, exactly. Awesome. So today, if you're running, because right now we're on Testnet, so if you're running a Agave client on Testnet, you should be able to install this in 30 to 60 minutes. All of the dashboards come out of the box, easy installation guides. So yeah, pretty straightforward.
How is this different from something like what Jito does with Jito bundles and the auctions there? And then also, I guess, with, I'm trying to remember the name of the servers. I know Triton and I think Helios have a similar service where it's effectively block auctions ahead of time. Like what's the difference here between those and what you're doing at Raiku?
Yeah, so one is today, it depends on how you want to look at it, really, because you can draw a few parallels to Jito today and how that compares to Raiku. But when you send a transaction or a bundle to the Jito mempool, MEV researchers is participating in that game. Out of that, historically, it was a 200 millisecond speed delay, but they've decreased that now to 50 milliseconds, which is then sent down to the validator once the most profitable bundle has been selected. And then the validator will then include that into the block. In Jito, historically, if I remember correctly, they have reserved about 5 to 6 million CUs or compute units, which roughly corresponds to, I think, 10% of the block, at least back in those days. Well, yeah. Now we've increased it.
Hopefully less percentage of blocks soon.
Exactly. So essentially what it does is that it breaks continuous block building. Raiku doesn't. So you will send the transaction straight down to the underlying validator in itself, where the, let's say, communication line or communication path is already pre-established. And this comes down to the ahead of time block auctions and the inclusion signals that we distribute to those applications. That's the primary difference.
Interesting.
So it comes down to then, okay, what benefits will this have on latency games, right? But also, due to the underlying nature of the inclusion signal, you will receive this up to 60 seconds ahead of time, such that you can plan for what transactions you want to submit, right? And that inclusion signal is sent today 40 milliseconds, but it will go down to 20 milliseconds.
Interesting. Okay, so to make sure I understand, because I have like a very basic understanding of Jito, so take this with a grain of salt. But so to summarize, like your differences that you described, it's effectively Jito has some X percentage of block space that it effectively reserves on all validators that are participating in the Jito network and running the Jito client in order to receive bundles. So that's sort of and as transactions get sent, they get sent to Jito's mempool, all the Jito MEV stuff happens, and then it gets sent to the validator. So there's much more latency there. Vice with Raiku, because the block size is sort of the block space is auctioned off beforehand, the transactions can just get sent directly to the validators themselves, normal leader schedule, normal things there. And then because that auction's already happened, the validator, as they're receiving transactions that are like should go inside of that auction's block space via the Raiku setup, they can just prioritize those transactions over the other ones and then just continue on. Is that a good summation?
Yeah, pretty much. So with Raiku, you have what you can call differentiated block space, which means like block space with different features that is specific for different needs, different application needs. And you can pretty much think of it as almost as validator plugins. So for example, one validator plugin can be inclusion signals. Another one can be ahead of time, as in more than 60 seconds, which comes with a discount. So discounted block space, which is a different feature that might be quite powerful. For example, oracles, because oracles, they have a constant order flow, but it's not necessarily transactions which are high value. So they just care about, will I get included at this specific time? But it's not necessarily something that they want to have included at the top of the block, for example, due to low value nature. So yeah, think about it as plugins for like different use cases.
It's interesting because this is one of those things that, you know, I had a very direct understanding of the problem set more before I became familiar with Solana, right? So like the problem of getting block space was more apparent to me in 2020 using Ethereum, right, than it is right now on Solana. Just as a regular user, right? So it's like, as a regular user, I often was like, hey, I don't really care when this goes through. I just need to know it's going to go through. I'm sitting here clicking the button, the transaction is spinning for 3 minutes and then fails. And that's just really fucking annoying. Like could we just schedule this for sometime in the next 10 minutes and know that it's going to happen for sure? And so it's interesting to hear us talking about it now in the context of Solana, which has much higher throughput, is much faster chain. I almost never worry about transactions not landing as an end user. But I think what a lot of maybe typical users don't understand is that's not necessarily the case for all systems, right? Like if you're running a system that requires a lot of bandwidth, a lot of speed, it might matter to you that 3% of your transactions aren't landing or whatever, right? And so this sort of solution actually becomes much more important when you're thinking at scale, which most end users aren't, right? Like most end users, and frankly, myself, right? Like just jumping into Phantom and clicking some buttons to execute a transaction here and there. And so this doesn't sound like a salient problem, but I think it is when you think about the broader architecture of what we're trying to build.
Yeah, I think it's quite accurate, as in end users today don't necessarily care about the certainty or inclusion problem. I think the only time they're exposed to it is during network congestion, which we will help to decrease, because once you enable certainty, then suddenly applications or developers, they don't need to apply retry logic, and with retry logic you will just decrease the amount of spam that is sent to the network. But yeah, it is for those cases where applications needs to think at scale, or for edge cases. Think, for example, high value trading, high frequency trading. In the context of high frequency trading, up to 96% of transactions are being dropped as a big issue. But also in use cases where you have, let's say, solvers that is submitting bids to liquidity requests. Once that bid has been submitted, the solvers are taking on a pricing risk from the time the bid was sent until the bid is being accepted and then ultimately executed onto the chain in itself. And all of that takes time, right? So if you can decrease the time frame and ensure the guarantee as well, that's a brilliant use case. So I think the use cases that we're talking about here is not necessarily use cases that most end users are being exposed to, but the transaction primitives that we're talking about here will really enable the scale. That's for sure.
Yeah.
Yeah, I think users in this circumstance, it's very much a ignorance is bliss problem, where they don't see it, they don't have to think about it until they really see it and they really have to think about it, or their application providers have to think about it, like times of network congestion. Yeah, I want to circle back to something you said earlier about the Raiku auctions. You said they can be up to 60 seconds before. How does that work? How does, like, as an application developer, I build an application, how do I participate in the auction of these? And how does that transaction ultimately get to the validator? Because like we talked about, like the application can send it to the validator's handling everything on the back end effectively. But from like the understanding of Solana transactions, like once the transaction is signed, it has a shelf life. It has an expiration time in the form of the latest blockhash. So it doesn't last 60 seconds generally. It's roughly like 13 seconds or so. So how does that work?
So it depends on the use case you have. For extensions or off-chain compute modules in itself, it will work differently than how you would interact with Raiku and the SDK as an L1 application. but primarily there will be two ways to submit transactions to Raiku and leverage the transaction types. If you just want to use the basic types, as in the basic types essentially enables deterministic inclusion, so it will be included no matter what. That's just a simple change, as in these are the endpoints where you should submit your transactions to. If you want to participate in the ahead of time block auctions and receive inclusion signals, then you would need to install the SDK, which we'll go live with a bit later, where you will have programmatic access to, and this is something that you will define in the config, which is specific to your use case, as in this is the time frequency in which I want to operate on. This transaction type A or B is what I would like to use, and then the SDK will give the choice on what pricing modules that the developer would like to go for. So, for example, a problem that we faced really early on was, how do you price an asset ahead of time, so basically futures market? This is a really difficult problem to solve, and we don't think we are the best one to solve it. So we're opening up for the chance where MAB searchers, for example, they can develop their own pricing modules, and then you basically open up a free market. So that's how the developers can interact with it. So there is a lot of flexibility. There's still a couple of things that we're figuring out in terms of like the incentive mechanisms and how fees are being split from the applications down to the validators. This we should hopefully have ready very soon. But yeah, those are the two primary ways you can interact with Raiku.
So you guys, you said that you're currently, on Testnet. So you've got some validators that you're working with on Testnet. Who's testing on the other side, right? So there's obviously the integration with validators, but kind of like what Nick is saying, the folks who are actually submitting transactions using your tech. Who are you working with? What sorts of use cases are you testing? What can you share on that side of things?
So right now we're running Testnet V1, which is pretty much the core construction of Raiku. So there's a couple of things it doesn't support yet that will come later in V2, which will be after the summer. So what we're testing for now is the installation process for the validators and really load testing the core construction of the Raiku network. So basically the coordination node. Right now, the coordination node is only living on a few instances, but in V2, it'll be fully decentralized. So that's when we will start to test the latency of sending out the different inclusion signals, how fast we can send information down from various different application types, completely down to the underlying validator, and also test for the edge cases of what happens if a transaction is not included by the validator in itself, like whose fault was it? That will come a little bit later. Now we're pretty much just testing the core construction of Raiku in itself, primarily with the validators, and then simulations on our end.
So the coordination layer, it sounds like, is its own decentralized network. Yeah. That's sort of dedicated to facilitating this. It's almost like an extremely focused and dedicated L2, right? Like its job is very narrow. It's not an L2 in the way that we normally think about L2s.
No, it's not an L2, as in it doesn't hold any keys, essentially. It's primarily there to coordinate messages between the different stakeholders. yes, you can compare it to a decentralized network, but there will be a limited number of nodes. So anywhere between 100 to 500 nodes. And what we care about is that those nodes are run by good actors on a good infrastructure layer. So basically, the data centers can communicate efficiently, and that you have good geographic coverage in terms of proximity of where we see certain transaction hotspots, right? So like New York, London, etc.
Got it. How do you ensure good actors in a setup like that?
That's a good question, and that comes down to a lot of the incentive mechanisms which we're currently hashing out.
Okay.
So hopefully we'll have a paper on this really, really soon.
Awesome. It's the whole idea of sort of extending the network is interesting to me, because I do think Solana, for years, right, the marketing was kind of anti L2s, right? And I understand why. You mentioned all the problems with L2s at the beginning of this call, right? Like there's these coordination issues, fragmentation of liquidity, misalignment of incentives, et cetera, right? But it's almost like a don't throw the baby out with the bathwater situation, where it's like, hey, just because we don't want to create a full, L2 doesn't mean we can't take some of the concepts of extending the base functionality of the network to improve the network. So, it sounds like there are still some unknowns with what you guys are building, but I don't see that as I don't see that as a bad thing. I see that, I mean, there are unknowns with. I mean, we said it earlier as well that Solana is still improving, right? We see that Solana is a very great chain, but we're not done, right? We're still making improvements to the network. We're
always building.
Exactly. And so it sounds like you guys have a really neat solution already, and some of these outstanding questions, like what I just asked, like how do you prevent bad actors here, is like, oh, well, we've got some ideas. We're working on a paper right now. Some of this we're building up for V2 type of thing. Yeah,
exactly. Yeah, it comes down to the incentive mechanisms of the overall, let's say, Raiku economy. This is something we've been focused on for a long time. However, we're only now starting to get ready to implement and test it in the scenarios that we're modeling for. So we should be able to achieve some good progress at the end of the summer. So let's see. We'll keep you updated.
Yeah, I am very interested to like see what you come up with, especially given, like you said, that coordination layer doesn't hold any keys or anything, right? So my whole concept of how do you build a distributed network that has economic incentive to maintain, good actors, sort of hinges on like my understanding of a traditional blockchain network, right? Which it sounds like the coordination layer is not. So how to map some of those same economic incentives over to a slightly different system is new to me, and something I'd be interested to dig into.
There's many different options you can go for. Like we've seen in Ethereum that some of the pre-confirmation players have merged pre-comps, which what I've traditionally called like base security, because it's like very similar to how you build rollups traditionally. They merged that with restake security. So like Eigenlayer, Jito, etc. So it does merge at some point, but restake security as well has its own issues. So there are multiple ways you can secure ancillary components to the network. The question is, though, what risk exposure will that lead to for the applications that is ultimately ending up building on this, right? So there's many different considerations to take into account, if not one of like the most difficult problems to solve for, to be honest. So that will be a fun one.
Interesting. So when an application, is trying to use Raiku, are their transactions submitted? They're submitted through that coordination layer, or is that sort of a side process? And they directly to validators?
Yeah, the transaction is sent to the coordination node on the Raiku node. Then the Raiku node figures out what is the CE usage of the transaction that has been submitted, what is the optimal inclusion path depending on the transaction type. Then it's then sent down to the underlying network in itself, which is the validator.
Got it.
So transactions go to the node, the Raiku node.
Yeah. So then it is, it is important, obviously, to maintain good actors, because it's not, you don't want a node that's going to drop transactions. It's kind of defeats the point of the system. Who is the, you mentioned a couple use cases, but like who do you think the first users of Raiku are going to be? Is it going to be high frequency trading systems? Is it going to be end user applications? Like what do you sort of, obviously some of this is a hypothesis, right? But I'm curious what the hypothesis is.
The simple answer is most DeFi applications on the L1 today, they will be able to participate and improve the overall user experience and performance of their underlying L1 applications by adopting some of the transaction types, which then will lead to higher protocol margins for the underlying app in itself. But also, let's say, at PerpDex, there the traders will be able to take advantage of price movements that they haven't been able to do historically. So the simple answer is the pre-existing native L1 apps today, but longer term, where you can create most value is by adopting this new way of building the application, so off-chain compute modules, right? So the biggest vertical that makes the most sense is finance, high-performance finance, which also includes DeFi.
So finance because of how valuable transaction inclusion is there.
Yeah, exactly. You want to beat the market.
The guarantee and the speed of getting your transaction to land. If it's worth a lot of money to you, it makes sense.
Exactly.
You mentioned traders being able to take advantage of price movements that they otherwise wouldn't. Could you explain maybe just step by step how Raiku facilitates that? Right. There's a little bit of a gap for me there, where this maybe is a good opportunity to like dig in and provide a concrete example for me.
Yeah. So if you have a off-chain compute scheduler or an off-chain scheduler that receives inclusion signals every 20th millisecond, that scheduler will be able to order the transactions, which comes inherently from its users. So let's say the traders and the market makers, according to the best business requirements or use case for this PerpDex. Since it receives the inclusion signals again 20 every 20th millisecond up to 60 seconds ahead of time, you will be able to confirm the execution of those transactions much faster than you would originally. And with that, you decrease the timeframes for basically getting a trade confirmation as an end trader in itself. Now, so that's with the transactions, but there is a dependency on real-time pricing feeds today, like basically oracles. Today there is limitations on how fast that can be. So I think that is a interesting industry challenge that has to be solved. Some players, they have made interesting solutions where they basically take in multiple different pricing feeds from decentralized sources and up to centralized exchanges. That is one possible way to solve it. So, because you do need to have the asset pricing to support the time frequency of how fast you can confirm trades, right? So, yeah, there are multiple things that would be relevant.
A few things to work on in parallel, because confirming the transaction quicker doesn't matter if you don't have accurate pricing information at the same speed.
Yeah.
Got it.
Spot on.
Gotcha. Yeah, this is going to be very interesting, especially once Alpenglow eventually reaches, testnet and mainnet, probably next year. Hopefully, that's like Anza's optimistic timeline, when they're quoting transaction finality at 50 milliseconds, which is crazy from what it is right now. It's going to be interesting to see. This has been such a great conversation, Robin. I would love to have you back on the show here in maybe a couple of months to talk more about, what progress you guys have made and
Testnet V2.
And Testnet V2. Yeah, that'd be great. As we wrap up here, I was wondering if there's any last minute things that you want to relay to the audience.
We are hiring big time. If you're an engineer or a marketer or growth, please go to Raiku.com. Always hiring.
Amazing.
What types of engineers are you looking for mostly? What skill sets?
Mostly core engineers.
Okay.
Core engineers, Rust, fairly low level experience. If you built, worked on a validator like client, fantastic, but Rust native.
Okay.
Amazing.
Sounds great. You heard it here, folks. If you are an engineer who fits the profile, go to Raiku.com.
Let's go.
Sounds like other things too, right? You said marketing, some other thing. If this sounds interesting and you're not an engineer, of course, still reach out, right? Like there are other roles and other ways to get involved. Well, awesome, Robin. Thank you so much. This was a great convo. I'm excited to see how V2 goes,
Thanks for having me.
I'd love to chat more about the challenges that you've solved once V2 testnet comes out.
Thank you, guys.
All right. To the listeners, we will see y'all next time.
Bye-bye.
Bye.
All right. Thanks for joining us for this episode of the Solfate Podcast. I hope you liked it. I know we did. We always have a blast recording with our amazing guests. If you've got a moment, please leave us a review in your podcast app or subscribe on YouTube. And I guess it's time to get some more coffee and get back to work.